Hey, how's it going everyone? I'm Nick, and in this video, we're going to configure an IPSec VPN between Juniper SRX and Cisco ASA using pre-shared key for authentication. We're going to use IKE v2 for Phase 1, and for Phase 2, we're going to use the ASA's relatively new Static Virtual Tunnel Interface, or SVTI. For those of you out of the loop, Cisco brought SVTI to the ASA back in January 2017, starting in software 9.7.1. Before then, your only option on the ASA was policy-based Phase 2 using ACLs. Now, with SVTI, you have route-based Phase 2, although currently it only supports static routes and BGP peerings. No IGP peerings across the SVTI yet. Still, that's a huge step in the right direction. So let's take a look at this and let's jump in. If you guys want to follow along with today's video, or you want to circle back around and try this in your own lab at home, then go to our website at node9.tech. This website has a post for every video that we publish, and each post not only lets you play the video right from the browser, but it also gives you access to the topology, plus the end configuration of all the devices. And if there's any additional steps that aren't captured in the configuration, like for instance in this one, setting up PKI requires a lot of commands that aren't visible in the configuration, well then those are covered as well. So it's a great resource to use during the video if you just want to reference the topology while I'm talking, or after the video if you want to set this up yourself. Here's the topology we'll be using for the SRX to ASA VPN. Over here on the left, you'll see we have SRX0 using a loopback IP of 10.0.0.0. Its internet interface will be gig000, and its public IP address will be this one ending in 138.98, and it'll be a /29. Now the interface it's going to use for its IPSec tunnel will be this secure tunnel 0.0, and the IP on that interface will be this one ending in 0.0, and it'll be a /31. Over here on the right-hand side, we have ASA0. Now the ASA doesn't support loopback interfaces, so we're actually going to have this interface gig01 configured as a LAN interface with this LAN subnet of 192.168.0.0/24, where the ASA is going to be 0.1. And we're going to use this to advertise via BGP to SRX0, so we have a test point for reachability and connectivity. The internet interface for the ASA will be gig00, and its public IP will be the one ending in 102.30, which is a /27. Finally, its IPSec SVTI will be tunnel 0, and it'll be using the IP address 0.1 and a /31. Alright, here we are on SRX0. Let's take a look at things and get our bearings. So if I look at my interface descriptions, I have my internet interface here on gig000 and my loopback interface on loopback 0. If I look at a terse route table, I can see here is my internet interface gig000 with a subnet of 138.96/29, but my IP address is .98 on that subnet. I also have my loopback interface here with an IP address of 10.0.0.0/32, and I have my static default route next hopping to my ISP at 138.97. So let's take a look and see if we can ping the ASA0, make sure we have reachability across the internet. And we do. Alright, let's take a look at our security. Because with SRXs, you have to be concerned with security zones and policies. So first we'll look at the security zones down here. So I have my internet security zone of www, and it's allowing pings and IKE and IPSec to the routing engine. And only my internet interface is participating in this security zone. And that's what we want. Then I have the corporate zone, and it has my loopback interface because this is where we're going to be originating pings from to test across the IPSec tunnel. And this corporate zone is my trusted zone. So that's why we're allowing all system services and all protocols. And this is also the zone that we're going to configure the IPSec tunnel interface into, ST0.0. And since we're going to have transit traffic originating from the loopback going through the secure tunnel interface, we need a policy to allow that transit traffic. So here I have a policy from corporate to corporate. So this is a intra corporate zone policy. And I named the policy permit any because that's what it does. It says source address any, destination address any, application any, so any protocol, then permit. So everything is allowed within corporate. If it's coming from a corporate interface, going to a corporate interface, it's permitted. And that's what we want. All right, so we're pretty much ready here to get started with our IPSec configuration. And I'm going to be moving pretty briskly because I have previous videos on my channel that covers the configuration of a pre-shared key authenticated IPSec VPN. So you can go back and check those out. They're really long and they cover all the ins and outs, the different settings and what they do. So we're just going to kind of move along at a healthy pace here. So first we need to configure IKE. IKE is phase 1, and specifically we need to configure the proposals for IKE, what we're offering to the peer for the IKE settings. So we'll create an IKE proposal and we'll name it IKE prop, something obvious. And for the authentication method, we're going to use pre-shared keys. For the Diffie-Hellman, which is how we spontaneously derive a shared secret key, we're going to use group 14, which is 2048-bit. For the authentication algorithm, all right, we're going to use SHA-256. Definitely don't use MD5 or SHA-1. Those are legacy and shouldn't be used if possible. And then encryption, we're going to use the industry standard here, AES-256. And finally, the lifetime, we're going to do something long, like 86,400 seconds, which is not only the maximum time here, but it also happens to be 24 hours. So that's a 24-hour period. All right, so our proposal is done. Those are all the settings that we're going to offer our peer that we want to use to set up the phase 1, the IKE tunnel. So now we got to create our policy. So we need to create a policy, and we'll name it something obvious like IKE poly. Now the first thing it needs to do is it needs to reference the proposals we just created. So I say proposals, IKE prop. The next thing we need to do is we need to configure the pre-shared key. We configured the method was going to be pre-shared key, but we haven't configured what the pre-shared key is, and that's what we do here under policy. So we're going to say pre-shared key, ASCII, text, and we're going to use this key right here. This is an SRX to ASA lab. All right, and that's all we need for policy. Now the policy's done. So now we need to move on to the gateway, and this is the peer-specific piece. The proposal and the policy can be shared amongst numerous peers if you want, but the gateway is peer-specific. So we're going to name it after our peer, ASA0. And we need to reference the IKE policy. So IKE poly. So now we have the IKE gateway, ASA0, and it's tied to the IKE policy, and the IKE policy is tied to the IKE proposal. So now all the IKE elements are tied together. The next thing we need to configure on the gateway is our peer IP address, because this is a static point-to-point IPSec tunnel. So that means we know our peer IP address and we need to configure it. So that's going to be this IP right here. We're also going to want to configure the external interface. That's a requirement. So that's going to be our internet interface, gig 000. And we need to configure version 2, because that's the version of IKE we're going to be using. And finally, on this one, we're going to configure the identities. If you don't configure the IKE identities, then they default to the peer IP addresses. So you use your own IP for the local IKE identity, and you use the peer IP for the remote IKE identity. Well, that's not what we want. What we want is we want to manually configure them so we can see how the ASA handles this later in the video. So on the SRX, for the local identity, we're going to use hostname. And the SRX just lets us configure whatever we want, but we're going to name it after our hostname, SRX0. And for the remote identity, we're also going to do hostname and name it after the ASA's hostname, ASA0. So we're using static IKE identities here. All right, so now we have our IKE configured. We're done with IKE. We can quickly take a look at that. We have our proposals. We have our policy, which references the proposal and defines a pre-shared key. And then we have our gateway, which references the policy and has some peer-specific settings like the IKE identities, the peer IP address, external interface where we're going to anchor the IKE and IPSec on, and the version. So now let's move on to IPSec. So IPSec, we need to first start with the proposal. So these are going to be the phase 2 settings that we want to negotiate with our peer. So we'll name it something obvious like IPSec prop. And we're going to use protocol encapsulated security payload. We'll use for the authenticating or authentication algorithm, we'll use SHA-256, which is this one right here, HMAC SHA-256. For the encryption algorithm, we'll also use 256, this time AES-256. And for the lifetime, we'll do something shorter. It will be, how about an 8-hour period, so 28,800 seconds. All right, so now we're done with our proposals. Now we need to create our IPSec policy. And we'll name it something obvious, like IPSec poly. And the IPSec policy needs to reference the proposals we just created. So there they are, IPSec proposals. And the next thing it needs to do is you have to decide if you want to run perfect forwarding secrecy, or PFS. And we do want to run it. And we're going to run it with the same keys, the same Diffie-Hellman keys that we used to set up IKE. So that's going to be group 14 or 20 48-bit keys. And just remember, perfect forwarding secrecy is where when it's time to renegotiate new keys for the IPSec phase 2 tunnel, it first reruns Diffie-Hellman so that it can rekey the phase 1 IKE tunnel. That way, if you do have an eavesdropper, they get flushed out of your IKE tunnel, and then you exchange your IPSec keys safely without any eavesdroppers. All right, so now we have the policy configured. Now we need to configure the VPN, which is peer specific. So we'll name it after the peer, ASA0. And first, we need to reference the IKE gateway that we created, which is also called ASA0. So now the IKE ASA0 is tied to the IPSec ASA0. So now everything's tied together between IKE and IPSec. We also need to tie in the IPSec policy we just configured, which was IPSec poly. So now all the settings we've just configured are all tied together. And finally, we need to bind it to an interface because this is a route-based VPN we're configuring here. So we're going to use secure tunnel 0.0. So if we take a look at our IPSec settings, you see our proposal, which are the settings we're offering to the peer to use for our phase 2 IPSec tunnel. Our policy, which references the proposals and configures perfect forwarding secrecy if you want it. And then finally, the VPN, which is peer specific. It references the IKE gateway, it references the IPSec policy, and it references the interface if it's going to be route-based. Speaking of interfaces, let's get that configured. So that's going to be interface secure tunnel 0.0. We'll give it a description after our peer, ASA0, and we'll give it an IP address, which will be 172.16.0.0/31. All right. And then we also need to remember to put this in the security zone. So show security zones. Earlier, we were looking at our security zones, and we need this secure tunnel interface to be in our trusted zone here, our corporate zone, along with the loopback interface. All right, so now our tunnel interface is in the corporate zone with our loopback interface, and we'll be able to originate pings from our loopback interface across the tunnel, no problem, because of our corporate intrazone policy we looked at earlier. So now we need to move on and think about configuring our BGP. So on the ASA side, on the secure tunnel interface, it doesn't support an IGP. So we either got to do static routing or BGP, and we're going to do BGP. Now with Juniper, in order to redistribute or export a route into BGP, you're going to need a policy. So let's create that policy first, because what we want to do is advertise our loopback interface towards ASA0. So we're going to create a policy, and it's going to be called export to ASA0. And we'll name the term something obvious, like loopback, because that's what we're going to be exporting. And we'll say from protocol direct, because the loopback is directly connected. And we'll say from route filter 10.0.0.0/32 exact. And if those two things are true, then accept. And even though there's an implicit reject, I'm going to make an explicit one. So I'll say term reject, then reject. So anything else will get rejected. So if I look at my policy I just created, it's called export to ASA0 with two terms. The first term is called loopback and says if you're a direct route and you're 10.0.0.0/32 exactly, then accept, otherwise reject. And that makes good sense because if I do a show route, my loopback interface here is a direct route and it's exactly 10.0.0.0/32. So now I have the policy I'm going to need. Now it's time to create BGP. So let's get BGP going. And we need to create a group. Juniper requires you to put all BGP neighbors in a group. So since ASA0 will be the only one in this group, we'll just name the group ASA0 and we'll reference our export policy, which is what Juniper calls the redistribution policy, export to ASA0. The next thing we need to do here is we need to define our neighbor IP, which will be ASA0 side of the tunnel, 172.16.0.1. And we need to define two more things. We need the peer autonomous system, which we'll use autonomous system 10. And since it's going to be iBGP, we'll be running the same autonomous system. Perfect. So let's do a quick commit check. Everything looks good. Let's commit. So now we've configured everything to bring up IKE, to bring up IPSec, to bring up Secure Tunnel 0, to allow Secure Tunnel 0 traffic to and from Loopback 0 because we put it in the corporate security zone. And also now we're running BGP and exporting our Loopback interface into BGP. So let's leave SRX0 and go over to ASA0 and begin configuration over here. We'll first do a couple of commands just to get our bearings. We'll say show interface, but include capital interface. Now here's all my interfaces on ASA0. Most are admin down. However, I have gig00, which is my internet interface, and gig01, which is my LAN interface. That's what we're going to be using the 192.168.0.1 IP address on, /24 subnet mask, and that's what we'll be advertising via BGP over to SRX0. All right, so let's take a look at show interface IP brief. You can see my internet IP is ending in 102.30, and my LAN interface IP is 0.1. Let's take a look at my routing table, show route. So here's my internet interface. You can see it's a 102.0/27. When you can also see that my IP address on the internet interface is 102.30. Here you have the LAN interface, which is 192.168.0.0/24, and my IP address is 0.1. And finally, you see my static default route, which is next hopping to my ISP at 102.1 out my internet interface. So let's quickly just do a ping to SRX0. This worked in the other direction, so we expect this to work, and it did. So we have reachability through the internet, which is good. So let's get started on configuring the ASA. So some of these commands are going to feel familiar with the commands you've seen on iOS if you've watched my previous videos, but there are some notable differences. And this is probably the first notable difference, which is you have to enable IKE on the interface you're going to land IKE on. So the first command we need here is crypto IKE v2, because that's what version we're using, enable www. And that's the other thing. On the ASA, you don't reference the interface number. You reference the name. So if you look here, all of these interfaces are named. So if we look at my, you don't need the do command on an ASA either. Another difference between iOS. So if you look at gig00, you can see that it's been administratively named www. So now throughout the config, if I'm ever referencing this interface, I actually reference www. So it's kind of interesting. All right, so after enabling IKE v2 on the internet interface, the next step is we need to create the IKE proposals, which unfortunately it's a little confusing, but Cisco calls the IKE policy. So crypto IKE v2, policy, and you don't name it. It's a sequence number, kind of like a route map. So we just give it 10. And here's where we're going to put all of our IKE proposal settings under this IKE policy object. So for encryption, we'll use AES-256. For integrity, which is the hash, which is what the Juniper side calls the authentication algorithm, we put SHA-256. Now, on the Juniper side, when you configure the authentication algorithm, whatever you configure is used for the integrity and for the pseudo-random function of IKE. However, on Cisco, you can have a different integrity hash and a different pseudo-random function hash. So if you want them to be the same, which we need to in order to sync up with the Juniper, we need to set the pseudo-random function also to SHA-256. Then we can set the group, the Divi-Hellman group, to 14. And we need to set the lifetime seconds to 24 hours, or 86,400 seconds. All right, so now we have our IKE policy configured, which are the proposal that we're going to offer up to the Juniper SRX, SRX0. The next thing we need to configure, and this is really different than iOS, is we need to configure the pre-shared key, but we need to do it under something called the tunnel group. So the ASA has these configuration elements or objects called the tunnel groups, and what you name the tunnel group is important because the name is supposed to reference the peer that it applies to. So if you're using default IKE identities, which are the peer IP addresses, then you would put the peer IP address here, such as this. That's SRX0's peer IP that we're going to be bringing up the IPSec tunnel with. However, we're using custom IKE identities. We're using the host name as the IKE identity. So I actually need to configure this as SRX0, which is what the SRX is going to be using as its IKE identity. And then you have to configure the type. So this is going to be type IPSec LAN to LAN, also known as site to site VPN. Now you get this warning here that if you're using IKE v1, you either need to use the IP address or use aggressive mode or use digital certificates. So that doesn't apply to us because we're using IKE v2, but just good to know. So now that we have the type configured, we actually need to go back in here and go to this subsection called IPSec attributes. And under here is where we configure the peer-specific settings, namely the pre-shared key and whether we want to turn off keep alives. So we say IKE v2 remote authentication. Just like iOS, the pre-shared key can be different between the remote and the local. With the Juniper SRX, you configure the pre-shared key, and it uses the same pre-shared key to challenge the peer and the same pre-shared key to offer to the peer when it's challenged. However, with Cisco iOS and ASA, you can use separate keys in either direction. We're not going to do that, so we're just using the same key in both directions, which is, this is an SRX to ASA lab. And it even warns us, hey, whoa, don't forget to configure the local authentication. So the remote authentication is how we're authenticating our peer. The local authentication is what we're offering to the peer when they challenge us. And let me get this copied. All right, so we're using the same pre-shared key in both directions. And then here is where we also configure whether we want to keep alives turned on. So on the Juniper, we didn't turn on IKE keep alives. On the ASA, they're on by default. So if we want to turn them off, we have to use the command isacamp keep alive disable. So I could have left it on, but I'm just going to turn it off just so it matches on both sides. And this isacamp, that's the old name or old term for IKE. So some settings on the ASA are still nested under this isacamp keyword because that's the old term for IKE. So it's kind of confusing sometimes, but all right, so now we're done with the tunnel group. And there's only one last IKE setting we need to configure, which is the IKE identity. And this is done in the global config. We need to say crypto. And here's that isacamp keyword again, identity hostname. Now notice a couple things. For one, here we are with isacamp again. So it's just for legacy reasons, this setting is still nested under isacamp, which is the old term for IKE. And number two, notice with the IKE identity, I can configure it to be the address. I don't get to set the address. It automatically uses the address I'm using to peer for the IPSec tunnel. or I can use the host name, but I don't get to set the host name. It automatically uses whatever my real host name is. So a little bit less control here on the ASA side, because on the SRX side, you can say host name and then you can just type up whatever you want, and it may or may not match your real host name. So just something to think about. You know, a little bit less flexibility there. So now we're done with IKE phase 1. Now we can go on to IPSec phase 2. So we start with crypto, IPSec, IKE v2, meaning it's going to be an IKE v2 type of IPSec proposal. So IPSec proposal, and we'll call it something obvious like IPSec prop. Now these are our phase 2 settings, right? So we're going to want protocol, encapsulated security payload, encryption, AES-256. And then for integrity, we're going to want SHA-256. All right, so there's our proposals. We're done with that. Next, we need to configure our IPSec profile. And now that is the IPSec proposal and the IPSec profile, that is common between ASA and iOS. So we're going to call this profile SRX0 because it's peer specific. And under this profile, we will set the IKE v2 IPSec proposal to be IPSec prop. That references what we just configured, and then we'll set the perfect porting secrecy to group 14. So we are using perfect porting secrecy, and we're going to use Divi Helm in group 14. And finally, we'll set the security association lifetime in seconds to 28,800, which is 8 hours. So those two configuration elements, the IPSec proposal and the IPSec profile, is where you put all the IPSec settings to negotiate phase 2 with your peer. So now we're done with IKE and IPSec, but at this point you might be thinking, hey, wait a minute. We haven't configured the source IP or interface, the destination IP that our peer is using. So how does that work? And plus, nothing has referenced any tunnel interfaces yet. So this is just something different between Cisco and Juniper. You saw on the SRX, nothing really goes under the tunnel interface. You just put the description, you put the IP address, and of course, whatever interface specific settings, but there's no IKE or IPSec configs on the interface itself. However, on the Cisco side, for both ASA and iOS, the tunnel interface has some important IKE and IPSec settings, and it's actually used to launch the IKE and IPSec. So let's get that configured. We're using interface tunnel 0. We'll name it SRX0 because that's where it's going. Our IP address will be 172.16.0.1, and it's a /31. And then we need to put some tunnel settings on here. So tunnel source is going to be interface www. So we're going to be sourcing our IKE and IPSec from our internet interface. So you can see here, this is interacting with IKE and IPSec. Tunnel destination, this is where we put our peer IP. So 107.22.138.98. So that's the public IP of SRX0. We also need to change this to tunnel mode IPSec IPv4. Now this is kind of interesting because on the ASA, you can only use the tunnel interface. Currently, you can only use the tunnel interface for IPSec. There is no other mode it can go into. But this looks like it's a carryover from iOS where the tunnel interface is used for GRE, IP and IP. It's used for MPLS. And so one tunnel interface can do all sorts of things, and you have to set the mode that you want to use it for, IPSec only being one of them. However, on the ASA, you can only use it for IPSec, but for whatever reason, you still have to configure the mode. And then the next setting we need here, the final setting, is tunnel protection, IPSec profile, SRX0. So here's what ties the tunnel and these critical tunnel destination and tunnel source settings to the IPSec profile, which references all the IPSec settings we had. All right, so let's get out of that and take a look and see if this tunnel came up. So this tunnel will show down if the IKE and IPSec aren't up. So it looks like it's already up. Let's see if we can ping across it. We'll make sure we can ping ourselves, and we can ping across it. So the IPSec tunnel is already up. Let's take a look at the IKE So here you can see status up active. We have one IKE tunnel or parent tunnel, phase 1 tunnel, and one child tunnel or IPSec tunnel or phase 2 tunnel. So this is what you want to see. If you don't have a child, then something's wrong. You're not successfully negotiating phase 2. So here you see the local IP address, the remote IP address. You can see we're using UDP 500, so no NAT is detected. Here's all of our settings, right? AES 256, hash of SHA-256, Diffie-Hellman group 14. And then we're using pre-shared key for authentication. Sign means outbound. It means how we're what we're offering for our peer to authenticate us. And authentication verify means how we're verifying our peer, how we're authenticating our peer. And here's the lifetime, which is 24 hours. And then here's the child SA or IPSec ASA traffic selectors. And we can do a detail here. And here we see a little bit more like our phase 2 settings, AES 256, SHA-256. We can also see that NAT is not detected. Here it says dead peer detection, which is that NAT keep alive is still configured. That's a bug. It's not actually sending anything right now. And here's our local ID, meaning our local IKE identity, and a remote ID, meaning the remote IKE identity. All right, so everything looks good there. You could also look at the stats if you're curious to see your in packets and out packets. This might be useful for troubleshooting. And you can see here that dead peer detection is in fact turned off. We haven't sent or received any. All right, and then another statistics we can look at is protocol statistics, IKE2. It's much more abbreviated, but here's some more statistics. We can also do it for IPSec. These are more like summary statistics. And speaking of IPSec, we can say show crypto IPSec SA, and now we can look at the child SA, which is called interface SRX0. It's a VTI interface. Local IP 102.30, peer IP 138.98. Traffic selectors are all zeroed out, which is normal. You can see we've only sent 5 packets, which were the 5 pings, but we're receiving 29. That's the BGP hello messages trying to neighbor up. And then here you can take a look and see some of our settings down here. So it's a LAN-to-LAN VPN, tunnel mode, perfect forwarding secrecy 14, IKE2, VTI interface, AES 256, SHA-256. So all of the settings that we configured can all be found here. And then we can also look at the stats. So how many packets we received inbound, 32, how many packets we've sent, 5. So all these stats are really good for troubleshooting when you're trying to figure out what's going on and what's gone wrong. So all right, let's go ahead and configure BGP. So with Cisco, you call out your autonomous system right at the initialization of BGP. So router BGP, and we're doing IBGP, so it's going to be 10 to match SRX0. Then I'm going to set the router ID. So BGP router ID, I'm going to set it to 192.168.0.1. So the SRX0's router ID will be its loopback 10.0.0.0, which also happens to be what we're going to be advertising through BGP. The ASA here, I'm going to set its router ID to be 192.168.0.1. All right, and then we have to configure our neighbor, but we have to configure under the right address family. We want to use the default address family, which is IPv4 unicast. And we're going to configure our neighbor here, which is 172.16.0.0. And the remote AS is going to be 10. And we're going to have to activate that neighbor. And then finally, with Cisco, you can redistribute routes using a policy like a route map prefix list into BGP, or you can just use the network statement. And the network statement just looks in your routing table, your RIB, and if there's a valid route, known direct, known through an IGP, whatever, you can match it with the network statement and it will just get it will get sent into BGP and advertise to neighbors. So we're just going to use the network command to bring in 192.168.0.0, the mask of 255.255.255.0, because that was in our routing table when I did a show route. That route right here is in our routing table as a connected route. And you can see BGP is already up. We have our BGP route up for 41 seconds here for the 10.0.0.0/32 coming from our neighbor 172.16.0.0. So that's looking good. So let's take a look, show BGP summary. So here's our neighbor. It's been up for a minute now. We're learning one prefix. So if I say show BGP, here's the prefix we're learning. It's IBGP. Next, hopping to through the IP address of the tunnel. Default local preference of 100. And here's my route. You can tell that I'm the one originating this into my BGP table because the next hop is all zeros. And we can look at these more closely here. So if I look at this route more closely, you can see the router ID of the neighbor is also 10.0.0.0. So that's SRX0's router ID. And then I can show BGP neighbors and look at my advertised routes. You can see I'm advertising that 192.168.0.0 route. And I can also look at that route in the table in more detail. And you can see that my router ID is 192.168.0.1. All right, so we already knew we can ping the other side of the tunnel. So now the question is, can I ping the loopback? And I can. So that looks good. But I need to ping the loopback, and I need to source it from this 192.168.0.1. But there's no source command on the ASA. So the way this works in the ASA is if you want to source it from a certain interface, you have to call out that interface first, and then the IP address you want to ping. But watch what happens. It doesn't work. So what's going on here? So the ASA has an interesting gotcha, which is if you're sending traffic from the CPU, the routing engine, or you're sending traffic to the CPU or the routing engine, the ASA really wants to receive that traffic on the interface closest to the source. So what I mean is, since I'm trying to ping 10.0.0.0, it really wants to send the packet from the secure tunnel interface from 172.16.0.1 because that's the interface and IP address closest to the destination. But I'm trying to source it from 192.168.0.1, which is on the far side of the ASA. It's on the opposite side of the ASA. It's a different interface. And so that traffic, particularly the return traffic, is going to have to traverse the state table, the flow table, in order to get through the ASA, get to the LAN interface, and hit that 0.1 IP address. And by default, the ASA doesn't allow that. So in order to make that work, there's a special command you have to use. And you can configure this command on any interface, but it's what allows you to send and receive traffic destined or sourced from the CPU or routing engine on a particular interface, even though the traffic is going to the state table first. So we're going to say LAN here. So now I'm allowed to send or receive traffic on the LAN interface, even if it's not coming in or going out of the LAN interface, even if it's coming in and going out of a different interface. So now if I do the same command, it's going to work. Now, just so you know, if I jump over to the SRX and I do my pings, it's going to work. And if I go back to the ASA and I remove this, then pings from the SRX stop working. So this management access command or feature on the ASA has to be turned on whether you're originating the pings from the ASA or receiving the pings from the ASA. So let's turn it back on. And now we go back to the SRX, and now the pings are working again. So you don't need that command if you're sending traffic to some host on the LAN interface. You only need the command when you're sending traffic to the ASA routing engine or CPU itself, because by default it only wants to receive or send traffic from the CPU in the correct logical direction that the traffic should be going or coming from. It doesn't want traffic to traverse its state table and then get sent back into the CPU or routing engine. And the reason why it's called management access probably is because there's a common situation where you have, let's say, a hub ASA and you have a bunch of spoke ASAs. And you need the ability to manage the spoke ASAs through your IPSec tunnel, which used to be policy-based, right? So you'd be at the hub and you'd be initiating a ping or an SSH session or, God forbid, a telnet session to an interface on the ASA, but it's an interface that's like the LAN interface. It's the interface on the spoke ASA that's facing away from the hub. And that did not used to be allowed unless you would put this command management access and then put the name of the interface. And that will allow traffic, not just pings, but SSH, telnet, whatever, SNMP even, to be picked up by the CPU of that ASA and processed. So anyway, good to know. And then just to wrap up, we can look at the Juniper side here, the SRX side. You can see BGP is up. And you can see here's my BGP learned route, 192.168.0.0/24. So there you have it, folks. That is how you set up an SVTI between a Juniper SRX and Cisco ASA using pre-shared key for authentication, IKE version 2 for phase 1, and SVTI for phase 2. If you enjoyed this video, give it a like, and if you want to see more, subscribe. Also, don't forget about our website at node9.tech, where we post all of the materials so you can either follow along in the video or you can set this up in your own home lab. Have a great day, everybody.